Hi, my name is Alex. I'm Managing Director at Flyability North America, and I'm here today to talk about sending drones instead of people in confined spaces and hazardous environments.
Hi everyone, I'm Greg from Pilot Institute. We train drone pilots all over the country.
Hi, my name is Haye from DroneXL, where we cover all the drone news on our website.
Welcome to the latest episode of the PiXL Drone Show, our weekly podcast where we talk to industry professionals about what they do in the UAS space.
From professionals who use drone to fly inspection missions to public safety users or even drone light shows, you will learn on the PiXL Drone Show that drones are much more than just toys. Hey Greg, how are you, man?
Not much. We're actually getting ready to record our 3 courses for mapping, and we are pushing to get this done today. Get a pre-release to our students in the group, and then tomorrow we're going live officially. So it's been a busy couple of weeks, especially for Ethan and his team editing all that.
Nice. Do the new courses, do they focus mostly on outdoors mapping, or do you guys also focus on mapping things indoors?
No, it's all outdoors, but really if you think about the technique, it's going to apply, but not nearly as much mapping as the guys we have on today, talking about Flyability and Elios. So if our listeners don't know about the company that we're talking to today, they created a drone that flies pretty much indoors and does inspections where you don't want to be sending someone, aka a nuclear power plant or a coal. Stuff where you don't want to have a person. So we'll be talking to them about this. What are you looking for as far as the discussion?
Oh, I would like to just know how they started the company, what the challenges are when you develop a drone, when you manufacture drones. I mean, these guys, I think, are based in Switzerland, so that's not necessarily a country known for production, unless we're talking about watches, of course. So I'm just curious to hear their story to get to... Yeah, and chocolates, if that's what you're into. I like drones better. I'm curious to see what he has to say and just get some more background on it. I mean, I've been to plenty of drone expos and conventions, and I think almost at all of them I would run into Flyability, and their drone is pretty distinguished. Or easy to recognize because it's a drone in a cage, and I think with their newest model, the cage and the design is slightly different. So I think it's going to be interesting to talk about about this drone more in detail.
Yep, and our guest is Alex Meldem. He's the managing director for Flyability in North America. And so we'll get started. I'm interested, the one thing I'm interested in is figuring out how they do the communication between the drone and the controller as you start to go inside of this complex environment. I live in Arizona, and I've always wanted to go explore old mines, but they're very dangerous. You don't want to be going in there. And I would love to be able to send either a drone or a ground robot or something, but there's always this issue with connectivity. So I'm going to be asking that question and see how they do this. So, all right, well, let's bring him in.
The new gold rush is going to start.
No, I just want to see what's in there. Quite frankly,
yeah,
I'm just curious because I see all these old mine shaft all around town in Prescott, because this is a mining town. Oh yeah, there every time I go run trails, I even found some that I think not many people know about, because I go explore some of the trails, and then you see them. If you know what to look for, you can see the old shafts and everything. So, let's bring Alex in. Alex, welcome to the show. We're really excited to be talking about this very, very specific drone.
Hi, Greg. Thank you so much for having me.
So before we go into the drone and before we go into Flyability in itself, let's go ahead and talk about you and how you became a drone pilot and kind of entered the drone space.
Sure. I was fortunate enough to kind of happen by a happy mistake on this field that eventually became a passion of mine. What had happened was I was living in the United States. My family is based in Switzerland. I was working here for a Swiss-based negotiation company running their operations in New York. And for family reasons, my wife and I decided we would go back to Switzerland. So we moved back to Switzerland, and I had no job at that point. I was fortunate enough to see a position at Flyability, and I put everything I had into making sure I got it. And so that's kind of how I happened to start working at Flyability. I think it took me all of half a day to realize that I was actually really passionate about what the company was doing and about the technology. So while there wasn't any design of landing in the industry, I think within a few minutes of being in it, I realized that this was the right space for me. I did business development at Flyability for about a year. So I was really trying to find new customers, new people who could have a use for this technology, and in doing so, I came to realize that the value that this drone, this piece of technology brings to the table goes so much further than just being able to provide visual data, and I'm sure we'll get into that later. So anyway, I was doing business development there. Got a even deeper passion for this technology. I would go out every day, basically fly for an afternoon just to get familiar with it. And I guess that eventually leads us to where we are today. It was an opportunity to come open an office out here, and since I had done this before for another Swiss company, I was the right fit for it. And it's been quite a fun ride ever since.
That's awesome. So how long have you been in the United States then?
So this time around, I've been here for a bit over 2 years now. We moved here with my family in Colorado to go set up the initial office that we had, and now we're in Austin. I hope I'll be here for a few more years, and eventually I'll be excited to go back to Switzerland, of course.
Yeah, Switzerland is an amazing country as well. So with a few years of Flyability under your belt, can you tell us a little bit about the history of Flyability as a company, where it's based, how it got started?
Sure. Yeah, I love talking about the story of Flyability because it just ends up being so relevant to who we are today as a company. So I guess the farthest back we can go is probably after the Fukushima nuclear power plant meltdown. One of our co-founders, Adrian Briot, who's today CTO at Flyability, was part of a team of engineers that had a mission to go gather visual data inside of this plant. They couldn't walk in because of the rubble, the flooding. They couldn't send ground robots in for that very same reason. So it became obvious that the only way to get visual data from in there was to fly in. However, at the time, it was still the very beginning of quadcopters kind of hitting the mainstream, and there were absolutely no solutions designed to fly indoors. So being the engineers they are, they built a drone that was designed to be able to evolve in those environments. And for those who've seen the Elios One, the solution is just, from an engineering standpoint, fascinating. You have this payload with the motors underneath it that keep the drone upwards in all situations, and then this cage that revolves around on 3 different axes. So the idea at the time was really to find a way to fly a drone into these spaces that are hostile to both human and ground robots, all while making sure that it can bounce around and that can be retrieved. There were no automated systems, algorithms to avoid collisions back then. So it really was on the mechanical side that you'd be able to save the drone. So they built this solution for this specific problem, and in building it and later on, bringing it to competitions and things like that, they realized that there was actually a huge need for drones that could fly indoors, which was kind of a weird concept in the past. And so realizing the potential there, they set off along with our CEO today, Patrick Thibault, to build this company that had one very specific niche and defined focus, which is visual inspection in confined spaces. Now that was back in 2014. 2 years later, they released the first solution, the Elios One, which met a high success with a lot of the early adopters. These people that had these very expensive problems to solve, and all of a sudden there was a solution to it. Of course, for those who flew the Elios One, they'll know it was a very hard drone to fly. It was completely manual. There was a cage revolving in front of the camera at all times. And with the complexities of piloting it, the fact that you had this cage turning around, you also had to maintain situational awareness in these complex indoor spaces. So it was a challenge. But then we moved through the second iteration, and we're at the third iteration today, and I'm sure we'll get into that eventually. So that's kind of the background on Flyability. We're a company that is based in Switzerland with a heavy relationship with the EPFL, which also led to other companies like SenseFly and Pix4D in that area. And so that's where we have our headquarters. We now have this office in the United States with a team of 8 people and poised to grow quite a bit over the course of the next year, and another office in Singapore where we're building our team out there too, and a small presence in China as well. And then Flyability is also, just on the last aspect of it, it's a fascinating company. I think our co-founders have a very interesting vision as to how a market should be approached, how, having this very clearly defined niche and path forward really benefited us over the years. And it really trickles down to, I think, everything we do as a company. Even the structure of leadership is different than anything I've ever seen before. And it creates an environment where, people are happy to be there. Most of them are completely aligned with the mission. And it's an important facet of flyability that goes beyond the technology. Because we can all adhere to the mission of the company, I think our customers have particularly enjoy working with us compared to other OEMs because we're very involved. We want to be there to help them. We're interested in the work they're doing because every time we know they're doing the work, we know we've prevented somebody from entering confined space. So on that aspect as well, it's the structure, the way it's run. It's a fascinating company and definitely a great company to be working for.
Yeah. So I was looking at your website earlier today, and I've seen you guys at various drone trade shows and expos in the past. So you had the first iteration of the Elios, then you had the Elios 2, and only recently you guys came out with the Elios 3. Can you talk us through the design of the drone, and then we'll get into the specs and all that good stuff as well?
Absolutely. So the Elios 3, I think, is really the accomplishment, today is the closest we could get to the vision we have for our technologies. I was talking about the Elios 1. It was a hard drone to pilot. It was very much a drone that was designed for a pilot rather than an inspection tool designed for an engineer. Yeah. We realized quickly that, the ease of use is very important. The ability to trace data matters a lot, especially in the scenarios in which we work. And so we had the Elios 2 that was, a step, definitely a big step up from the Elios 1 in terms of maneuverability, data quality, reliability. But it was still missing a few components. And the way our Adrian Brio frames it, which I think is a great way to explain, is essentially the Elios, we always set out to build our equivalent of the iPhone. The Elios 1 was your Nokia phone, right? You could play snakes on it. You could throw it around. Yeah. You could leave it in the washing machine. It would still work. That's what the Elios 1 is. It's a rudimentary piece of technology that can do things that, nothing else is capable of doing. The Elios 2 was maybe more like your Motorola flip phone. You had access to the internet. You could upload some songs. You could still do calls, text, and play Snake. But there was only so much that you could do with it. And in that sense, the Elios 2 definitely had a lot of new, smarter features than the Elios 1, but it was still limited in the growth and the applications you could have for it. And then comes in the Elios 3, and the Elios 3 is our iPhone. The Elios 3 is a platform that is entirely now, I think, it is a tool for engineers more than it is an aircraft for pilots. It is built in a way where, and I'll talk about this over and over again because it's one of my favorite things about the Elios 3. But it's designed in a way where it's not a static solution. It's a solution that's going to evolve fundamentally over time. We have the building blocks that we'll need to create something much more than what it is today. For example, we have payload bays, so you'll be able to add additional payloads onto the drone to really, so that it really is the right tool for whatever you're trying to do with it. But we also have a lot of powerful onboard computers that today have limited functionalities, but that over time, will enable us to do much more with the drone than really any other drone is capable of doing today. So I think the magic of the Elios 3 and that follows this path that we've been on for the last few years is that it's not a standalone solution anymore. It's not something that you buy and that will remain the same over the course of its lifetime. It is poised to evolve in many different ways, be it on the OS side, if you compare it to the iPhone, or in the apps that you'll be able to add on to it over time or build for it as well. And so in that sense, it's one thing today, and it will be something completely different should we have this conversation again in a year's time.
Can you actually show the drone? I know you have it next to you because I think this design on this drone is so unique. You will see this drone from miles away when you go to a conference or if you see it in the wild. Just because first off, it's actually bigger than I think most people think this thing will be based on the video that you have on your website. But it's got that cage around. Can you talk about the cage and kind of the purpose of the cage and then also maybe talk about the lights that are on it?
Sure. Well, let me run you down to a few things. So I guess to start with the cage, it's something you'll recognize for many of our drones. We have this geodesic dome made out of pentagons that enable us to protect the drone in cases of collisions. We now have a drone smart enough, which was not the case for the 1 or the 2, to technically have everything it needs to avoid collisions should we decide to go down that path. In reality, though, the environments we fly in are extremely complex. Think of, for example, and in some cases they even have moving parts. But for example, if you were to think of a scrubber on a coal fire plant, so a scrubber is where all the exhaust from the coal burner goes into after it's been burned. And the scrubber has for function of cleaning it. Now, cleaning that exhaust so that they can release some of it into the air and use others for other functions later on. But anyway, these structures have hundreds of metallic pipes that crisscross each other with little nozzles to spray water into the exhaust. And so these environments are extremely complex, and sometimes we have about this much space between the wall and the drone to fit through. And so in order to ensure that this drone was capable of going anywhere it needed to, in order to ensure that it could get into physical contact with objects, which is needed in some cases when we're fitting through very tight spaces, the cage is there for that. It's essentially a tool that or an aspect of the drone that enables it of really going through extremely tight spaces without risking anything hitting the critical components or disrupting the flight in any way. It's a very visual feature, and it's an easy way to recognize our drones. At the same time, it really has been key to the evolution of our product, being able to bounce around. The Elios 1 could roll everywhere. The Elios 2 could bounce into things, and this one is the same. It can bounce around and remain airborne. There are very few collisions that could take it out of the sky, if really any at all, as long as you're piloting in a reasonable fashion. So that's for the cage component. Now, there's been a few changes to the overall design. We have these ducted fans now that they enable us to have a much more focused and centered point for the downwash, which helps with stability, but which also helps carry all these added payloads we have onto it. We have the lighting system now, which has always been a key feature of our drones. The places we fly in don't have natural occurring light or light bulbs and things like that. So we have to bring the light with us wherever we go. Now we have, I think, 16K lumen if you push it up all the way. So a whole lot of light, enough to shine up a big storage tank from one side of the other. But they're, again, designed specifically for the job they're going to do. So you can see we have various panels. When you're flying in very dusty environments, you get the issue of seeing all the dust in front of the camera because it's picking up the light, reflecting it, and so it really obscures the vision. What we do in those cases, for example, is that the two front LED panels turn off automatically so that only the side panels are shining light, so you don't have any direct light in the dust in front of it to help with navigation. In other cases, and this is not something we've invented, but something inspectors have been doing for a good part of the last 100 years, essentially, you can turn these on and off selectively so that you can cast lighting the way you want it to. Imagine there's a wall here. If you were to position the drone straight in front of it and beam light straight at it, you wouldn't see much at all. You wouldn't see cracks, pits, bumps, anything of that nature. But if you were to turn the drone just a little bit and turn off those lights that would just add noise to the image, you only have one focused beam that's shining light in one specific angle, which allows you to see all the cracks, pits, and bumps that there may be on the surface. Now, inspectors do the same thing. They take their flashlight, they shine it at an angle so they can see that stuff. This is just one of the features, where we try to replicate what engineers would typically do when they're performing inspections, so that they can keep doing it in the same way, only without going inside the asset. A few more notable things to talk about, maybe. One that I really like is the shape of the drone. It was one of our engineers that came up with it. He inspired himself off of insects to build the shape. Italian engineer, they're so passionate about appearances, and they really did it well. It has this unique kind of shape and appearance that is, that feels like it's straight out of the future. We have the LiDAR puck up here, very important part of this drone that I'm sure we'll get into later. And you can also see that we have this an additional payload bay here with a dedicated payload port in the back, so that you can add additional payloads to it, so you can have both the mapping and whatever else you need to do at the same time. Maybe two more facets, or just one more, the payload. So we have a 4K camera on the RGB camera. We have a FLIA-3 thermal as well, which is used for example, detecting steam leaks in nuclear power plants, inefficiencies in installation, stuff like that. And then we have these three BIO cameras, which, working together with the LiDAR, enable the drone to not only understand the environment it finds itself in, but also where it is within that environment. So using the combination of both the LiDAR and the BIO cameras, the drone is able to understand its positioning within an asset to, for example, today remain stable. Over time, it will enable it to return to signal, return to home. Why not even perform inspections autonomously? But so these are really this is what the inspector uses to see, the visual data. This is what the drone uses to see where it is and where it's going. Yeah. And I think that kind of covers the base. features.
So I wanna dive a little more into the cage and the design. I mean, adding the cage, of course, adds a little bit of weight to the drone. It makes the drone bulkier, so maybe less easy to fly into cramped spaces. And also, if you look at some of the video footage that you guys have on the website, in environments like a refinery, I mean, there's a lot of pipes, there's a lot of bolts, things sticking out. Is there any risk of that drone getting stuck or hung up on something that sticks out? That's, as a pilot, you might not be able to see when you're flying?
Oh, there is, and it's that's why training is so crucial when you adopt this drone for the first time. The cage adds some complexities for sure. For example, if you have a little hook going out there and you get yourself stuck on that hook, there are situations where it will be completely impossible to retrieve the drone through its own means, just because it's hooked onto the cage. The same way, if you look at the shape, it tapers out off of the sides, meaning that, for example, you can also wedge it. So say you're fitting into somewhere where you can barely fit up here, but you keep pushing it, it'll get wedged and eventually stuck. And we've seen that happen in the past. If you will, I think the risks that are posed by the cage still are lower than the risks of not having it. And one of the big things is just offering peace of mind to people. Again, the way we see our tool is not an aircraft for pilots, but an inspection tool for engineers who don't necessarily have much exposure to piloting drones. Having this cage around it gives them the peace of mind that if they were to make a mistake, the drone is going to remain airborne. It's not going to come crashing out of the sky. And there are situations where the cage, is maybe not desirable, maybe because it adds too much volume to fit where you need to fit. With the design of the Elios 3, I think those situations, although we're not at that point yet, but where the cage will be expandable at least to some extent.
Do you foresee that as obstacle avoidance gets better and your drone is already equipped with LiDAR, that at some point you might not even need the cage anymore and you just have a smaller, lighter drone?
I think we're all hoping for a day where that comes. The reality still is that today the algorithms to avoid obstacles, especially in tight, narrow, complex spaces with little lighting, dust, and things like that, are difficult to rely on. I was talking about the VIO cameras earlier. Those cameras are, at the end of the day, like eyeballs. If they're obscured because dust is clinging to them, they won't see anything. So it really is the extra weight, the risks that come with having the cage, I think, is the price to pay to offer our customers peace of mind. And again, when somebody buys one of our drones, we make sure that they go through a training process that helps them identify those types of situations. It's kind of a different way of flying a drone because you're not looking at it while you're flying it. You need to have a level of situational awareness that is, I would say, higher than what you typically have with other drones. And so it's particularly important to ensure that people have the tips and tricks or skills available to them to ensure that every time they fly in, they'll know for sure that they can get the drone out.
Yeah. So I've ever since I started watching the videos about the drone, I've been wondering, how do you solve the connectivity difficulties of being inside of a metal pipe and going around the corner? How do you keep that feed to go back to the drone?
That's a tricky aspect of operating our technology. The strength, we'll often ask, okay, well, how strong is the signal? How far can I go? And the answer we have to give every time is, it depends where you're flying. So the metal pipe example, that's not one we're too concerned about. Metal is great for signal. It reflects the signal around, it bounces around. You have the range in a metallic environment is often not a limiting feature. The limiting feature will be more battery life than it will be range in those environments. There are other environments where it's much more tricky. Sewers, for example, or mines. Our drones are used a lot in various mineral environments, such as sewers. And in those sewers, you need to go down the manhole and then get into the sewer system. And so you already have 190-degree angle right there. And then it'll start, it'll have a slight incline in one direction, and that's another angle. And that's when we get into tricky situations. Now, there are some solutions that we've built. For example, we have what we call the range extender, which is an antenna box tied to a powered 60-foot cable that you then connect to the remote control. And this antenna box can be dropped in the environment where you're flying. So in sewers, they'll drop it through the manhole, so it's in the sewer system with the drone. In nuclear environments, for example, when they're trying to get into high radiation areas, obviously they don't want to be too close to the drone, and there's a lot of thick concrete in those environments. So they'll use a ground robot to bring the range extender into the radioactive environment and then fly the drone out from there. So we have solutions to some extent, but then there's also the aspect of, well, indeed, they're like back to the sewer example. You can take that first 90-degree angle. You can probably take a second 90-degree angle, but if you're trying to get out through a different manhole, you're going to have a hard time, and you'll most likely lose signal, because at that point there's no amount of range or cables that can save you from the loss of signal. This is also something we talk about a lot in training. We try to have a lot of notifications or ways to inform the pilot that the drone is losing signal, and a lot of it comes to planning. We always do what we call a recon flight before we perform an actual inspection, and that's a flight where you get into the environment and you really fly as far as you can, and just to see what rigidity you have with your signal. Over time, hopefully that's going to be less and less of an issue. Again, the backbones to build automated features such as return to signal are there. It'll just be a matter of implementing them over time.
So there is a technology available out there that will allow you to do this. Is this the Holy Grail at the moment for you guys, or is it something that's just too expensive and you can't implement it, or does the technology not exist at all where you can go and do this without a repeater? What's the solution?
Today, I mean, the perfect solution is you can fly anywhere and always have signal, right? In reality, though, we're limited by the laws of physics to some extent when it comes to how the signal moves through a given environment. The waves move through a given environment. I don't know that with the current technology there is a full-on solution to never have to have signal, unless the drone is doing the work on its own, which is probably going to be which at least for the foreseeable future is the solution, is that the drone is not only capable of understanding the environment, but navigating it and gathering the data it needs to gather while it's navigating that environment. But a Holy Grail solution to the signal, if there is one out there, it's unfortunately not one we're aware of.
Yeah. So just to kind of round up all the specs, can you tell us also the price of the drone, the flight time, and the waterproof and dustproof ability of the drone?
Sure. So the flight time of the drone will depend on how much payload you put on it. Without anything on the drone, you'll get a flight time of about 12 minutes. With the LiDAR on it, you get 9 minutes, and then with additional payloads along underneath a certain weight limit, you'll probably end up having 8 to 7 minutes. So there's a kind of array. If you shave a few minutes every time you add weight on it. Now that's going to sound excessively short to people coming out from the outdoor drone world, where you're used to having batteries that last 30 minutes to an hour. The reality is, and the saving factor for us, is that the environments we fly in are small. There's only so big an environment you can fly in an indoor space. And so while the battery can be a pain because you need to bring the drone back and swap it out, it's funnily enough, flight time is not the biggest concern that people have in the use of this technology. They're much more concerned about the size, for example, than they are about the time they can fly it, because the workflow of bringing the drone back, swapping the battery, is not too difficult a workflow to have. And personally, I kind of like having a clear-cut break every 10 to 12 minutes, because the situational awareness is taxing when you're flying this drone. You're totally focused into it, and so having just a second to breathe while you swap a battery is never a bad thing.
In a nuclear environment, right?
For example, yeah. You may not want to touch the drone when it gets out, but you're happy to have a little break.
Yeah, I can imagine.
And then, so for the other specs, you mentioned there was flight time, price, and what was the last one?
Waterproof, dustproof, and range potentially.
So we don't have the official certification on the IP rating yet. I think we landed at a 4 and 6. I need to double check. But so we have like the amount of dustproofing and waterproofing we need for the environments we fly in. I'm trying to see, but we don't have the certification yet, so I don't have those numbers at the top of my head. But essentially, it can take a splash. It can take all the dust it needs to take. We fly it in cement silos all the time, which is the nastiest dust around when it comes to drones. There's really no risk as far as dust goes. And then for water, we splash it. It will never survive being submerged, or actually some have, but it's not supposed to survive being submerged. And then for pricing, it depends a little bit on the package you go for, because obviously, different people have different needs. A service provider will need way more batteries, a range extender, and all that stuff. Whereas somebody who's just using it on site for an outage once a year won't need all that fun stuff. I would say the average price, including all the whatever software needs to be purchased, whatever training needs to come, the spare parts and all that, we see average purchases around $60,000. For the most part, we'd fall within that range. And then range, signal strength. The transmission systems we use are extremely powerful. In an outdoor environment, you could probably fly kilometers on this transmission system. In the internal environment, it really depends where you're flying. If you're flying in an area where there's a lot of metal, you're probably not going to have any issues regardless how far you go. If you're flying in an area that has a lot of concrete, cement, or rock, then it'll be diminished with every turn. I like to speak of it imagine it being a beam of light. So long as you can see the light, you'll have signal, but eventually, after enough 90-degree turns, you don't see any light coming through anymore, and that's where you don't get your signal.
Yeah. Can you talk about the 3D live map that's available on the drone? Because I think that's a really cool feature.
It is. It's that's one of the most exciting novelties, I think, of the EOS 3. So we have this lidar pucker on the drone, and in order for the drone to understand its environment, like I was saying, and understand where it is within that environment, it needs to do a couple things. It needs to map the environment, and it needs to use the VIO cameras to understand where it is within that environment all at the same time. So the processing that happens for the drone to remain stable today is enough processing to basically create the map of the environment it's flying in. So the drone is processing all this data in real time on board so that it can remain stable. But at the same time, it's also processing the data so that when you're done with your flight, you can just plug in your drone and have your map ready to go. And as you know, when you're flying, you see the map populate in real time on your ground control station because it turned out to be a feature that, I was mentioning really dusty environments earlier. There are times where you can't actually see where you're flying. You see nothing. A coal-fired burner or boiler is a good example where dust is flying everywhere, so you can't see where you are. The LiDAR can see through the dust. So the LiDAR becomes as much a navigation tool as it does a tool for the drone itself to understand or to remain stable. And because all that processing happens in real time through SLAM, once you plug in the drone, the map is ready to go with all the points of interest. So, when you're doing your inspection, you see something that's like, oh, this is something we need to check out. You can hit a button on the remote control, and it'll tag that area on the 3D map once you upload it to your computer.
So, quick follow-up on that. You mentioned the burners inside of a coal plant or something. How did they do inspections before that? Did they have to send someone down in there? Well,
that's the crazy part, right? And the coal-fired burner is a really good one because ASME provided us with numbers and the differences of process between doing it with drone and doing it with person. In the past, they would have to shut down the entire boiler. They'd have to wait about 3 days for it to cool down at a temperature at which people could enter. Then they'd send the people in. It would take the scaffolding crew about 2 days to build scaffolding throughout the whole thing. So they would scaffold every inch of the boiler so they could see every inch of it. And once that's done, they would send the inspection crew in. The inspection crew would typically be at work for a day or two. And then they had to take out all the scaffolding, which is another 3 days. And then they could finally put the machine back in operation, which, with energy intensive assets like that, getting them offline costs a lot of money, and having them offline is complete loss while it's happening. So now we go from this workflow, I think that was about 11 days through the traditional method, to a workflow that's about 3 days. You still need to let the asset cool down a little bit, but the inspection portion itself takes, all of 4 or 5 hours of flying to get the whole thing mapped out and inspected. And then you fly out. If so long as there's no maintenance needed, they can put it back online. And that the coal-fired boiler is an interesting one. The one I like most though is nuclear, also because of the numbers that are just crazy. So in a nuclear power plant, if they suspect, for example, a steam leak, they need to reduce the output of the plant so that the radiation in the reactor room goes down to an acceptable level for an operator to get in there. Of course, full suited, all protection. And then the operator can go in, and that process of cycling down takes 2 or 3 days, and then they can send somebody in and have a look and come back out, and it may be nothing was happening, but they didn't know that. Whereas with the drone, they don't need to reduce operations. In a lot of cases, they honestly don't care if they radiate the drone too much, because the saving they make in a 10-minute flight, it ranges between $500,000 to $1 million, and that's just 10 minutes of flying the drone, which is just crazy. On the coal-fired boiler, we're talking about $500,000 in savings, but that's over the course of a week of time saved. Whereas the nuclear power plant, it's 10 minutes of flight that is worth $500,000 to $1 million in saved reduction.
Crazy. Does the drone glow afterwards? after you come back from that nuclear inspection? How do you clean that up? Actually, that's a legit question, I guess. How do you clean this thing up when it comes back?
So for most nuclear power plants that use this as part of their workflows, they actually have two drones. They have one contaminated drone that always lives in contaminated areas and one clean drone that they use for the rest of the plant. I could tell you how many drones are stuck in nuclear reactors and how many of our drones are stuck in nuclear reactors in the United States just because they were abandoned there. It got too hot for them. They were too radiated and they were just left there to die. You'd be surprised by that number. But yeah, the drone itself, so once it's contaminated, there are some cases where they can let it sit for a few months and then take it out of contamination. In most cases though, when it gets to that level, it just remains in contamination for the duration of its lifetime and they use it in those contaminated areas when they need it.
Does it affect the performance of the drone at all? I mean, if it's contaminated, can you still charge it and fly it again later, or is that?
So it's an interesting question, and it's a good time to be talking about it. We're currently working with the Department of Energy on this massive project where they have these underground vaults filled with bins that have nuclear waste that's been in there for like 50 years and that was never designed to be removed. But that nuclear waste needs to be removed. The state of Idaho said, we don't want it here anymore. Please, federal government, get it out of there. So that project is entirely relying on the Elios 3 to map out those environments so that they know where they need to dig to extract the material. And to validate that they were able to use it for this, they put it through radiation testing. And the funny story is the timeline was short with the release of the drone. So we gave them one of the very early prototypes to do the radiation testing on. They ran the testing. It got up to 4 grads before having issues, and the issue was at the SSD level. 4 grad is a lot of radiation. It's enough to kill somebody like that if you're actually exposed to it as a human. And so anyway, it went way beyond what we were expecting, and so the computer was the first thing to fail when we expected other things to be problematic before that. But it took far more radiation than anybody thought it'd be capable of taking, and so really, and these are levels of radiation you wouldn't typically see in a nuclear power plant unless there's some kind of actual issue going on or that level of exposure to the drone. So I'd say we're above any threshold that the regular user would ever have to face in terms of issues with radiation. We mistakenly designed a drone that's extremely hardened to radiations without really having the intention of doing so.
That sounds awesome. So is it fair to say that the two biggest selling points really are safety, because you don't involve people in those dangerous environments, and the second one being cost savings that you just explained?
Yes, and that's absolutely correct. I'll nuance it just a little bit. On the safety side, which, that's what we get excited about. We're like, awesome, somebody didn't have to climb into this awkward, dangerous space to go look at something just for the sake of making sure that machine is running. But on the safety side, what we're doing is not so much reducing the risk as it is eliminating entirely. And so there's this hierarchy of risk control, of various controls you can do to manage risk. And of course, elimination is the best one. And in this case, we land in places, and I love seeing these posts on LinkedIn where you see these inspectors that show a picture of themselves climbing through these really tight spaces, obviously uncomfortable, obviously a dangerous situation. And then the after picture where they're just sitting outside on a foldable chair, piloting their drone inside of the asset with a little Coke or something. And that's the beauty of this technology, is that we're completely eliminating the risk that these people used to expose themselves to for the sake of looking at pieces of machinery. And then on the cost saving, there's two different sides of it. There's one, you're significantly reducing the outage time. So I was talking about nuclear power plants earlier. What we're doing there, we're not cutting any costs, so to speak. We're reducing the time where they lose production and thus lose profit. So there's that side of it, reducing the downtime, and then there's cutting the costs that are tied to the inspection, which fall more into operational expenses. Where the case of the coal-fired boiler, it took days and hundreds of thousands to build the scaffolding, whereas now you don't have to face any of these costs. In most cases, you don't even need a permit for confined space access, because at no point are you breaking the plane of open air and confined space.
So you guys with Flyability have been working on all this stuff for now a number of years. Over that time period, which industries or which customers first got it, first understood the value that you guys were bringing to the table, and then where, as a result, did you then sell the most drones?
So I think utilities, power generation, at least for North America, is the most active industry we have, most notably because so easy to tie the benefit of the drone with the cost saving and the risk saving. It's very transparent there because loss of production is a big deal and affects all the users on the grid. So we've seen utilities be very quick to adopt. Even kind of like the major utilities like Constellation now they're called, TVA, Duke Energy. They were all really quick to adopt this technology because they were looking into innovative solutions to avoid these issues that we solve. We also got quite a bit of traction, I think, on the energy side of things, mostly petrochemicals and oil manufacturing in general, where they also have energy-intensive processes where downtime is extremely painful. Loss of production is very painful to their bottom line too. So they were pretty quick to see the light and adopt the solution. I'd say the most scale that we're seeing now is definitely lies with utility groups who now have adopted this as their basic tool for inspection. So we have some of our customers where they need to, instead of saying why they want to use the drone, they need to justify why they're not using it if they choose not to. And I think a lot of major companies also have like these ambitions to reduce the amount of fatalities they have over the course of a year, and this is a really good solution for it. Of course, over time, we've seen a lot of people come out of the left field. The biggest left field, I think, is on the agricultural side of things. We don't really think we'd have much value there. It's not energy intensive for the most part. It's not. It's rarely critical or urgent when they need to do inspections. But it turns out, like if you look at a company like Cargill that has tens of thousands of assets around the country, even though it's a smaller saving compared to the nuclear power plant per asset, it's interesting enough for them to want to deploy this at a large scale. And in fact, I think it was a month ago now, we announced that Cargill invested $4 million in the company in the last series. So we're seeing traction from companies where we really didn't think we'd see it. It's exciting to see because we got to a point where people know us enough to come to us with their problems to see if this would be an adequate solution. And so we've got new applications coming out every day.
That's pretty awesome that you, from an area that you didn't expect you were going to sell drones anyway. Not only do you sell drones to Cargill, but they then turn around and invest in your business.
It was pretty exciting. It was a fun process. And, it's funny because we started that conversation. I think it was 2 years ago at commercial UAV as well, when we met the drone, or the person who ended up leading the group at the drone group at Cargill, Calvin Reeve, and we were able to announce it. I think it was two years later at the commercial UAV. It was kind of full circle, nice moment.
Congratulations!
Thank you.
Where are the drones manufactured at the moment?
In Switzerland, and people are often surprised to hear this, but we actually have the engineering and manufacturing on the same floor of the same building, and these two groups work hand in hand. Well, and it ended up being it's something that we really want to have engineering and manufacturing working together, owning the whole process with externalizing as well as possible in the manufacturing process, because it enables us to have really quick feedback loops. If we realize there's an issue with the batch of drones, we can go back and figure out the source immediately, have the engineers come into production, work with the production team to make sure that whatever issue we found is alleviated. So this all happens in a building in a small town named Bode, right outside of Lausanne in Switzerland. And that's where those drones are both designed and manufactured.
So a quick follow-up on this. The BlueUAS in the US is kind of the big talk right now. Is this something that you guys are interested in, or does that really not matter too much to you?
So the BlueUAS is a complicated topic for us. I was talking about the work we did with the DOE. That's one example where we've managed to work with the federal government despite these new regulations coming in, because they were able to get a waiver for the use of our drones, which now enables the DOE to use it. With the DoD, it's much more complicated. We get requests on a weekly basis almost from the Navy, for example, who want to use our drones to inspect their ships. And the unfortunate thing is that today there's no path forward for us or for them because of this BlueUAS requirement. And the story behind the BlueUAS is they wanted to find a program that would enable this group, the DIU, to sign off on drones for use, fairly narrow use, which was small infantry groups having a reconnaissance drone. And that was the original scope of this project, as I understand it. But unfortunately, they got tacked on with much more, which is basically find drones that the federal government can use. And that's just not the approach and the idea they had behind it. Now, we worked with them on several occasions trying to figure out is there a path forward here. I think the issue fundamentally lies in the fact that we would have to make concessions to the quality of our technology to meet some of the requirements they have today, all while maintaining a reasonable price line. And they don't necessarily have the mechanisms to onboard products like ours that is, for example, strictly forbidden to use in military applications. The Navy can use our drones to inspect their ships, but we will never sell a drone to anyone wanting to use it in an infantry setting, for example. That's one of the clear tenets of the company, is that our drones cannot be used for any type of offensive military action. And so because of this limitation, it makes things pretty difficult with the DIU and the BlueUAS concept, although we're working on finding a solution. I think, if half of the country is benefiting from the use of it, those who serve the country should also be able to. There's no reason, for example, that a naval ship, which there are hundreds of them, should dry dock to perform an inspection, not knowing if it actually needs maintenance or not, which, is a gigantic downtime on the ship. A lot of taxpayer money goes into that, when they could do at least the inspection at sea before deciding, do we need to dry dock the ship or not? So we're working on it. We're hopeful we'll find a path forward, because there's a lot of different actors at the DoD that really want to get their hands on this at the DOT level too. And hopefully it's something we'll be able to tackle in due time. But today we're not able to sell to the DoD, for example.
Gotcha.
So Flyability is based in Switzerland, a country not particularly known for low wages and stuff. You guys are a drone manufacturer. Then we've had COVID, chip shortages. Like, how challenging has it been for you guys to start and grow a drone manufacturing business out of Switzerland in the last couple of years?
It's been tricky. We're fortunate to have a lot of smart people that are very passionate about what they do, who also saw the writing on the wall when it was time to see it, and were able to at least put some plans into place to enable us to maintain production. We didn't really have any issues with production, fortunately, during the COVID period. It's indeed expensive to hire in Switzerland. At the same time, it's a country of watchmakers and all this fine, precise manufacturing and engineering. So it's a really good fit for us, and it's also just the birthplace of the company and where we have ambitions to grow it. I think the cost that we put into it transfers to quality over time. We have a very small team of people that know exactly what they're doing when they're manufacturing these drones, which is why we don't have hundreds of drones output each month. It's just that we want to maintain this. It's a complex tool, and that's how we want to approach it and how we want to see it. And so while the manufacturing does indeed have a cost doing it in Switzerland, I think it has an impact on quality and down the line on the reliability of the product and the trust our customers can put into it. It's never an easy position, especially for somebody at a company trying to bring this in for the first time, saying like, listen, this tool that costs more than any reasonable car, it's going to be able to save us these millions, because it's going to do something in a way that we've never done it before. And if it could get lost in there, and if depending where it gets lost, it could cause issue. But trust me, it's not an easy pitch to put right or to present to a company. So we really come in to reinforce that message, to give them every guarantees that they need to ensure that there's quality, that the product is built with quality as a priority, that there's a solid support system behind it. It's work. It seems to be paying off, but it hasn't been easy.
Oh, I bet. So where can people buy the drone right now? Do you have a reseller network? Do you sell it directly to the customer? How does that work?
So we have a network of distributors in the United States. I think we work primarily with MFE Inspection Solutions out here. They're a tech company that specializes in NDT products, which is a really good fit for us because they understand the tech side of things. They're able to perform maintenance support for our technology, but at the same time, they're all basically inspectors, at least at some point in their past lives. Very good fit for us. We also sell the drone directly. Typically, we always try to do what's best for customers in terms of where they get the drone from. So if it's somebody that, down the line, like Cargill, for example, that's going to buy dozens of drones, we'll work with them directly because they'll need an infrastructure to support it globally. But for an inspection company that serves, oil and gas refineries in Texas, for example, it makes much more sense for them to work with MFE because then they have that level of proximity. They can go to their offices for training. So there are various means to acquire our drones. We always try to push people in the direction that we think is going to be best for them.
So with the Elios 3, you have a very highly specialized drone that is made for very specific use cases. Do you have any competition? Like, are there any other manufacturers out there that make drones that do the same or that do things almost the same, or where you think, oh, maybe I don't know, Skydio might come up with a drone that is able to navigate indoor space, or maybe DJI will launch something.
I mean, DJI almost have with the Avata, right? No, it's we're in an interesting position on that front because the barriers to entry to what we do are very high. Acquiring the trust of these big industrial groups to send these expensive pieces of technology into their assets is not something that's easily done. And even if the price was, half or a quarter of what it is, it wouldn't solve the issue of the high level of trust that needs to be had in order to do this, which we've already gone over because, we were there first for the early adopters and all that. So, I mean, there is competition. We see competitors come and go, and we have over the last few years. I mean, a little tongue in cheek is that we like seeing competition. It's not always easy being alone and being first because every single door that needs to be opened, we have the burden of opening them. So when we see competition, people adopt their solutions usually because they're cheaper. Being honest, the cheapest solutions, they're exploring the idea. So they go for that solution. And when, the discussion I usually have with them is, okay, fine, let's talk in 6 months. Because at the end of the day, the amount, building what we've built takes, a huge amount of focus, time, and investments. It's not easy to build a reliable drone to fly inside. And because we have the privilege of being first, everybody's always playing catch up with us. And that puts all the competition in a difficult position. But, there are also other segments of our niche that are up for grabs. Look at Brink, for example, what they're doing with with drones that are designed to fly indoors for public safety, search and rescue applications. It's great to see them come out because the approach is smart. It looks a lot like ours to some extent, where they're extremely focused on some narrow verticals. But say a mine buys, a drone from Brink for search and rescue, it's all benefit for us because they'll start using drones indoors and thus develop a system to use drone indoors and maybe a base to start adopting our technology. So we want to see new players come out. I think the mistake most of our competitors have made so far is they've tried to replicate exactly what we're doing, just at a cheaper price point, thinking that we'll lower the cost, we'll get the customers they can't. I don't think that's the best calculation. Taking the approach Brink took of trying to find where we don't have a good level of penetration yet, and then pushing in that direction is the right way. And Brink, of course, has a wonderful story behind it that explains why this is the niche they're going for. Again, competition comes and goes. And as far as like Skydio going in 10 places, maybe, DJI maybe, but again, I think to build the amount of trust that needs to be built for somebody to adopt and scale this type of technology and their energy intensive assets, it's not a line of credibility that Skydio has built so far, that DJI has built so far. And again, you could say that eventually algorithms will alleviate the need of having a drone that's specifically built to fly inside. And that may be true for some applications, but what happens when you're in a really dusty environment and all your senses get clouded by the dust, which, is most of the places we fly in. They're never clean. They're always dirty. You need a specialized solution for those environments. And so we don't foresee much risk. Of course, they may take some of the applications, but we don't see it as being a predominant or area of concern.
Yeah. So I want to talk about remote ID because you're one of these companies where this is going to be a huge conundrum, right? The FAA is going to require all drone manufacturers to have remote ID for aircraft that are built technically as of this month, right? But it's pushed down to December, mid of December. But your drone pretty much never flies outdoor. It's an indoor drone, more or less. So you probably don't have much of a GPS feature available in the drone, but the FAA is going to force you to port remote ID in there. But not only that, but you technically, if you follow the regulation, you can't have the drone take off unless it has a GPS location in order to send it through a remote ID, which you will never have because you're going to be inside of a tube underground or somewhere. So how does the drone? Well, first off, how are you guys working on a solution for this? Can you even apply for a waiver from the FAA that says, hey, this drone is never going to be outside and we don't need this? Or tell us more about how do you deal with this?
Remote ID keeps me up at night. We knew it had to come, right? I think anybody who's flown a drone, like at some point realized something's missing. There's an element missing to the fact that you're able to fly this anywhere you want without any type of tracking. So the concept of remote ID I'm all about. I think it's something we're going to start seeing expand to the entire world, especially now that ASTM has a standard out. I know a lot of other countries are looking into it. It is a difficult rule for us because indeed most of our drones are designed to fly inside. There are cases where they are flown outdoors, even just for comfort. So for example, if you're doing a tank inspection, you may want to sit a few feet away from the entrance of the tank and just fly it in. There are situations where it is flown outdoors, but it's really not designed for that. At the same time, the FAA rule was very unclear until recently, if I can even say it's clear today. So we're playing catch up. We fortunately have, again, smart people who are passionate about what they do, who found solutions fairly early on in the game. Even with missing pieces of the puzzle, we're able to identify solutions for us to move forward. Now that everything is out there in the open and that the requirements are clear, the ASTM standards is out, we're trying to figure out what the right approach for us will be. We never like having our developments pushed in a certain direction due to regulations that apply to us, although they're not necessarily meant to. But it's the name of the game when you're in an industry. So we're working on figuring out what the right path forward is. We have multiple solutions that are ready to go, depending on what our conclusions are as we move through it. But I think like most companies, we're still trying to figure out what the F is going on with the remote ID.
Definitely sounds like that. If we step back a little bit and kind of look into the future, like what are some of the things for Flyability that you're most excited about for, let's say, the next 3 to 5 years?
Well, I think that as our solution becomes easier to use, we're going to start seeing meaningful scale. The way our technology scales within a company today is that, take an unnamed oil and gas company, XYZ Energy. XYZ Energy has like 5 different refineries. And one refinery starts using the drone, they'll talk about it to another refinery who may choose or not to use the drone. But because or at least because it used to be hard to pilot, there were certain levels of barriers to entry to true scale where somebody at a corporate level looks at this and says, okay, well, this is a tool we can scale out now. With the Elios 3 being easier to use, providing data that goes beyond just visual inspection and also tying into goals of digitizing assets and things like that, I think the next 2-3 years for us are really going to be the years of scaling, where we put a bunch of work into acquiring this customer base, of building the trust relationship. They've proven that it works for them. They know it does. And so we're starting to finally get attention of, the highest levels of these big companies who are like, okay, well, maybe we need to start talking about how do we expand this to a company-wide program, making sure that there are the checks and balances in place that need to be had to manage this at scale. And so these are discussions we're having with a lot of big corporations at the same time. I think over the next 2-3 years, the big thing for us is going to be seeing the solution become a kind of one-off, like there's this group inside that does quick services left and right, to being a solution that's just present at every site and part of the workflow for every time or before every confined space entry deploying this drone being part of their workflow. And that's exciting. If keeping in mind that the primary mission of the company is to replace humans with robots in confined spaces and hazardous environments, the fact that this technology is easy to use is finally going to enable us to actually bridge that gap and at scale prevent human beings from entering these dangerous places because the technology is easier to use and deploy.
Wow, I can tell you're not passionate about this at all. So it's been an amazing discussion. I love hearing that. These are use cases that we don't really hear about because, we see people flying drones up in the open, but all of this is all happening kind of behind the scene in a way. So we're getting towards the end of the interview, but there's always one question we'd like to ask our guests, which is, what's your favorite drone to fly when you just go out there and you want to fly?
This might fluster a few people, but the Mavic Mini, the original one, it's the perfect drone in my opinion. I've crashed it into more things than I've crashed some of my Elios drones, and it stands strong, it stands true, it can go far. It struggles a little bit with wind, but I rarely go anywhere without taking my first iteration of the Mavic Mini with me.
Wow, that's awesome.
There you go.
Yeah, we get a lot of people actually saying that, just a small drone, portable, easy to fly and take it to different places. So Alex, thanks a lot for being with us today. This has been very enlightful. Where can people find more information about the drone in itself and maybe even connect with you if they had questions or something?
Sure. I think our website has the keys to everything. Y'all can find me on LinkedIn if you want to, but we have all the information about everything possible and imaginable, use cases, tips and tricks, training, support material, all that good stuff on our website. It's a good place to go if you want to find more information about our drone. Besides that, we have a series of road shows where we're traveling across the country more or less throughout the year. If we haven't yet been, we'll probably be near the city of whoever's listening to this in the next few weeks. you look it up on our website, you'll figure out where to meet us.
Awesome. Well, thank you so much. It was a great interview.
Thank you. It was nice being here. Thanks for your time.
Thanks for joining.